shows the hidden details. The thing which we cannot see directly but we need to mention in the drawing, it means the hidden details. How we can represent it? It can be represented like this: medium dashed, 1 space, 2 space, 3 space. Likewise, with using this we can draw hidden edges with this line. It is a medium dashed line. Construction line. What is the use of this construction line? Construction line can be used to stretch the projections. When you will be in the orthographic projections, you will be drawing top view from the front view, side view from the top view and the front view. So at that time you need to take the projections. You will get the brief details about how you can use this construction line in the chapter of the orthographic projections, and you will have a better practice over there only. It is used during any sort of drafting. The line thickness would be very fine. It should be a very light line. It can be said as a faint line. Faint means very light line. Another one would be dimension line. It is used to indicate a dimension. A dimension is very much necessary parameter for any sort of drawing, so that a dimension line can be created as a very fine line, but not as fine as this construction line. It should be slight thicker than a construction line. You can denote a dimension like this. It can be used to have a dimension line. What is the extension line? It is used with the dimension line. Again, it is a fine line. It would be same as this dimension line, same thickness as this dimension line. And as you can see over here, these are called as extension line. The locator between 2 points. If I want to measure this distance, then my fingers would be extension line, and the marker which I am showing to you is your dimension line, and you will write dimension in middle of it. I am repeating, if I want to measure this portion, so my 2 fingers are the extension line of it. The marker which is in between my finger, it is dimension line, and the dimension will be written in the middle of this marker. Now we will see the center line. I have drawn a circle, but if I do not draw center line, then I cannot specify the circle's center. Yeah, of course, I have drawn a circle if I am drawing manually using the compass only. So there would be a spot of the compass on paper. But if I have made several arcs in the same drawing, then I may be mistaken using those spots. So we need to specify the center of the circle. How we can draw this? A center line can be a long line, a long dash, then some space, and short dash and some space. As you can see over here, I have given you an example. It is circle center, long dash, space, short dash, space, long dash. Very simple like this. Another one would be ghost line. It shows the possible movement. If I want to extend any line in the parameter, let's say if I want to extend this marker to this point, so it is my future scope. In future I may extend the length of this marker up to this my fingers level, right? So what I will do, I will draw ghost line, which is a very fainted line. as you can see over here in the chart, it is very fine dashed line, very fine. Sometimes if we are drawing in the color, you can use various different color so it can be properly highlighted. Next is cutting plane line. It shows the position of this cross section. It is a thick line with the arrows. Now, how we can use this line? Let's say this, I want to cut this marker from middle. To see what is inside it, I will cut down this marker from middle of it. So at the middle I will draw arrow and thick line, and I will write section AA or section BB or CC or whatever. But over there you can use this cutting plane line. Then hatched lines. I have cut down the position of this cross section. I have just cut down the marker and I have mentioned the section AA, but my surface would be clean, so I cannot understand that whether it is a section or not. So over there I will draw 45-degree lines at equal distance. How it will look like? It will look like this. It will look like this. It shows where it is solid and it shows where it is hollow. Another would be long break line. It shows that a line is shortened. It is a fine line with a zigzag line. I am giving you example in a bit. Another one would be short break line. It's again object shortened or cut away. Medium with the curves. Long break line or short break line are one and all equal to same. Now let's see, if suppose if this marker is 2 kilometers long, if I am considering this as a round steel bar and it is 2 kilometers long, then what would be the thing? Can I able to draw a 2 kilometer on a A4 size paper? It is not feasible. So what I will do, in the section I will just cut the section of this portion and will denote this portion with these lines, either long break line or the short break line. Next would be leader line. If I want to point out something in a drawing, then I should use a leader line. It would be a fine line with the arrow. With this arrow, we can attach a comment or angle or dimension to any object. If I want to comment anything to a detailed section, then I can use this leader line. Now, it is a technical drawing of a fighter plane. It have all the specifications and all the details of this fighter plane. It is a exploded view of this fighter plane. As you can see over here, various sort of parameters have been written which need to be followed when assembling is done. As you can see over here, proper assembly have been done in the hidden line. Or a technical thing can be represented as simple as a spoon. If I want to make a spoon, then also I need to have some sort of technicality. This is a, you can say, a complete sketch. Over here, the technical drawing of the spoon, which is multi-view orthographic projection. If I am seeing spoon from the top, then what would be the thickness of this point? What would be the breadth of this point? What would be the thickness over here? What would be the thickness over here? If I am looking from the side, how this curvature bend, what would be the radius of it, what would be the depth of this point, I need to specify. If I cannot specify, then I cannot make a simple spoon as well. So technicality is thing that without any sort of technicality you cannot create any sort of manufacturing. Or a technical drawing can be as complex as a spaceship. It is the outlook of a Mercury spacecraft. It is the technical specifications of a spacecraft, and it is the cutaway diagram. It is represented in the multi-view. It is the cutaway diagram, and it is a isographic projection diagram of any sort of drawing. This is the top view of orthographic projections, so that as you can understand that all the technical specifications have been included in this orthographic projection. When we were looking at this chart, I said that when you go towards your right in the chart, in the orthographic projections, maximum technical details would be included. When you go towards the left, you will be seeing a thing like this, less technicalities. If you are seeing a picture of a spoon, can you imagine what kind of technicalities have been used in this? It is a sheer sketch itself. Now we will see that what kind of applications of tools can be.
Hi, so let's continue the discussion of geometrical constructions for line tangents and arc tangents. But first, what is a tangent? A line tangent to a circle is a line that is perpendicular to the radius and touches the circle only at one single point. The intersection of these two lines is called as tangent point. Now, where do we need tangents? In machine drawings, very often we will have to gradually merge a single line into an arc with a smooth curve, and also we have to connect two arcs with another arc, making the transition by a smooth curve. And this is where we need tangents. We'll proceed with explaining the construction of an arc which is tangent to given arc with radii r1 and r2 and with the centers as x and y. The required radius of a tangent arc is r3. Take x as center and radius equal to r1 plus r3. Draw an arc a dash b dash. Similarly, take y as a center. Draw an arc c dash d dash with radius equal to r2 plus r3. The arcs a dash b dash and c dash d dash intersect at point P. With point P as center and radius r3, we will draw an arc which will be tangent to the given arcs at points M and N respectively. Let's now erase the unwanted curve segment. And here we go. We have just drawn a tangent arc to given arcs. Another frequent requirement in engineering drawing is to gradually convert a curve into a single line. For example, do you remember this object? For this type of construction, we need to draw an arc tangent to a given arc and the given straight line. So without wasting much time, let's just do it. This straight line AB and arc DC of radius R1 need to be connected with another arc of radius R2. For that, draw a line A dash B dash parallel to the given line AB at a distance of R2. Now with center of arc DC, draw an arc D dash C dash of radius equal to R1 plus R2. This arc D dash C dash intersects the line A dash B dash at a point P. With P as center and radius of R2, draw the final arc. This arc makes the line AB at point M and arc DC at point N. MN is the required tangent arc. Pretty easy, isn't it? Let's now move further to ogee-shaped arc tangent between two parallel lines. But first, what is an ogee curve? Ogee curve is also known as reverse curve and is a combination of two arcs that are reverse of each other. Now AB and CD are the two given parallel lines. Join points B and C and bisect the line BC to obtain its center point T. Further bisect line segments BT and CT. From point B, draw a perpendicular line to cut the bisector line PQ at E. And from point C, draw a perpendicular line to cut the bisector line RS at F. With points E and F as the center points and radii equal to BB and FC, draw arcs BT and CT. The arc BTC is the required ogee curve. So this is how the tangents are used in engineering drawing. Interesting, isn't it? Time for a quick recap. In the last session, we were exposed to the fundamentals of drawings, the concepts and types of drawings. Let's now go over some important geometrical constructions. But first, what is a geometrical construction anyway? Geometrical construction is a process of drawing different shapes and figures and manipulating them with the use of drawing tools. Okay, the study of geometrical construction starts by understanding lines and angles. Lines have different types such as straight lines, parallel lines, and perpendicular lines. Angles also come in various flavors like right angle, an acute angle, and an obtuse angle. In this presentation, we will understand how to divide line, how to draw a perpendicular line, then dividing an angle in n equal parts. Sounds a lot and difficult? Let me tell you, it is not. Alright, now we will take a look at how to divide line into 7 equal parts. First, consider line AB of any length and draw line AC making an angle of length